Hello, this video was created to assist in simulating the Automated Greenhouse Environment System project. It will take you through the steps required to simulate the greenhouse using Proteus. As you can see, the simulation on Proteus is as shown, which is also included in the zip file. Its name is ages, a.g.e.s. In order to run the simulation, you need to open the Arduino IDE, which looks like this. Then open the Arduino IDE file. So it's named as ages.ino. It's an INO file. Once you open it, it will pop up like that. Then, in order to copy the file into the Proteus simulation, you need to change the preferences of Arduino. So you need to go to File, and then Preferences, see them down here. I've already changed the requirements. However, if you ran it for the first time, you would find these 4 boxes unchecked. These are the main boxes you require, which is compilation and upload. These two are just to enable code folding and to display the line numbers. Once you press OK, the Arduino software will be able to create the .hex file, which is required to simulate the Arduino on Proteus. Another thing is to go to Tools. Once again, I've already done this. However, is to go to Tools, go to the Board section down here. It says Board, and select the Arduino Mega 2560. Finally, you'd also have to include libraries, which are also included in the zip file. So the libraries are zip files, therefore then they do not need to be unzipped or extracted from the files. They are just added as .zip files. So if you clicked on that, you would then go to the location. Where is it? Simulation. Yep. And here they are: the growth temperature and humidity sensor, the master library, and the keypad library. Those are the only 2 libraries that had to be downloaded. The rest are included already for Arduino, programmed internally, which were for the liquid crystal LCD display and for the EEPROM. Once you've done all of that, then you just simply verify the code. And then you'll see at the bottom left here it shows that it's compiling the sketch. So once again, you just need to add the zip files, change the board to the Arduino Mega 2560, and in the preferences, make sure that you select compile and upload. These 2 are not necessary, they're just to include the line numbers and to include code folding. Once that's done, you will find your hex file over here. So just drag that. So you see this section here shows .hex. So you need to copy and paste this file location. So you select it like that, and then you copy by holding Control on the keyboard and pressing C. Then you go back to the Proteus simulation. You hover the mouse above the Arduino microcontroller, the board. You then right click and select Edit Properties. Once you're within the Edit Component menu, you then use the Program File section to select whatever address is within there, and then just paste new address by holding Control and then pressing V on the keyboard. Once that's done, you then go to the bottom left here and you simply run the simulation. As you can see, Welcome to Ages has been displayed on the LCD display. The light sensor reading is showing, the moisture sensor reading is showing, and the temperature and humidity sensors readings are showing. The solenoid valve is linked to the soil moisture sensor. The LDR is linked to the light sensor, and the DHT temperature and humidity sensor is linked to the 12 volt DC fan. The keyboard is shown as well. So the variables have been stored already within the EEPROM, just for simplification of the code, so of the video. So if I just drop down the light, as you can see, I can manipulate the amount of light being shone on the LDR. The closer the light, the more the brighter the reading of the light on the display. So you see right now it's showing 95%. When I reduce it down to a certain amount, you'll find the light down here, the light, the bulb will turn on. So once I drop it down, you can see the relay has pulled the switch down, allowing the 12 volt supply to power the light. Additionally, also the soil moisture sensor, if I reduce it, you will find that the solenoid valve will receive power, thus allowing water to flow through the solenoid valve, allowing permitting the plants to get water. The DHT sensor has the humidity and the temperature. So if I show you, actually, let me just show you the temperature. Saved variable for the temperature. So this temperature has been stored to 40 degrees right now. Set temperature is 40 degrees Celsius. The reading is 39.5 degrees. So once it cycles through, if you read the LCD display is 39.5 as well for the temperature, clearly. If I increase the temperature above 40, as you can see here, it's displaying 39.9, also there 39.8 or 9. It's a bit odd. ProTube's does have a bit of an issue. Oh, there you go, 39.9, yeah. ProTube does tend to delay regarding the readings sometimes, but in the hardware test, it's all with real time. So yeah, so once the value reaches 40 degrees, the fan will above 40 degrees, the fan will then get power through the relay, pulling the switch, supplying the fan with 12 volts. As you can see, all pins, all control devices can work at the same time. There's no issues. If the water, let's say, if the soil moisture reading goes above the required amount, the switch will then stop the flow of current, then stopping the water supply, and as you can see, there's no issues with the rest of the control methods. They continue to work depending on the sensor readings. So once again, if I drop the temperature below 40, see, the switch flips from on to off, stopping the fan. If you take a closer look, you can see the fan is slowing down. It'll be 0.55. There you are. So gradually the fan slows down on ProTube. However, in real life it should be immediate. And also the light. If I increase the light, it'll flip from on to off. As you can see, it's already done. Thank you for watching. I hope this video has been helpful. Have a good day.